Welcome to Learn to Build and Build to Learn AWS IoT series. In the last video, we have explored different power related functions and their use cases. Now we'll discuss about I2C or I2C interface followed by hands-on activity using an OLED display. I2C is a two-wire protocol for communication between master and multiple target devices or slave devices. It consists of two wires, SCL, serial clock line, and SDA, serial data line. SCL is used to synchronize the data transfer, whereas SDA is used to transfer the actual data between devices. Master device takes control of the clock and initiate the communication. As you see, multiple target devices are connected on the same bus, so each device needs to have a unique address that master will use to identify the target device and transfer data. For a hands-on, I'll use ESP32 as the master and the OLED display as the target slave device. For ESP32 with Micropython firmware, you'll get both software-based and hardware-based implementation through soft I2C and I2C class. There are two built-in I2C hardware controllers, I2C 0 and I2C 1. In case of I2C 0, by default 18 and 19 are configured as clock and SDA, whereas for I2C 1, 25 and 26 pin number are configured as clock and data line. But any available output capable pins can be configured as clock and data line. Because of the dedicated hardware peripherals and less CPU intervention, this is faster and more reliable. In case of software I2C, CPU needs to handle all the overhead of generating clock signals and transferring data, so it is slower, less efficient, and less reliable. Similar to hardware I2C, you can use any output capable pins as SCL and SDA line. For the demo, I will use a 12864 OLED display module. I have already connected OLED ground and VDD to ESP32 ground and 3.3 volt. SCL is connected to GPIO 18 and SDA is connected to GPIO 19. This OLED uses SSD 1306 driver IC. So first I will download the display driver required for this module and we are going to use MIP to install that. So first let's import MIP, then MIP install SSD 1306 and it's installing and it is installed in lib directory. So let's refresh and we can see it's downloaded and installed. So for software I2C and hardware I2C, both cases we need to import the corresponding class from machine module and then we can create that I2C object passing that clock and data line in case of software I2C. But in case of hardware I2C, if you want to use this hardware controller, then you have to choose 0 or 1. And if you have already connected to 18 and 19 pin for I2C, then you can just initialize I2C and passing that controller number means 0. In case if you want to use different pin other than the default one, then you can set something like SCL, then the pin number, and similarly SDA, then the pin number. To save time, I already wrote some code. Let me walk you through. So first, from machine module, I have imported pin, I2C and soft I2C, and during hands-on, we'll try both. And then I wrote couple of function like init to initialize that display module, then show message to display the message and clear the screen. I am going to use hardware-based I2C implementation. So I will use I2C. Then I'm passing this hardware controller number 0. If I create an I2C object without passing a a clock or data pin, then it will expect that it is connected to 18 and 19 GPIO pin number, which is true in my case. But I personally prefer to pass the pin explicitly for better readability. So instead of using this, I prefer to use this one. Then I'm going to use this SSD1306 module and SSD3606 underscore I2C class to initialize the OLED object. And here I have passed 128.64, then I2C object and the hardware address. So if you remember that multiple devices are connected to same bus, so we need to pass one unique ID of each target that this master controller will use to transfer the data. So this is the address for this OLED display. You can find this address from the spec. Also, you can find it programmatically. So there is a method called scan. You can use this scan method to find the address. For example, okay, so let's try to find this address for this OLED driver here. Import the relevant classes, then initialize the I2C object. Then let's try I2C scan. And we found one address here. So let's convert it to hex from this decimal 60 number. Here you go. You can find the address and you can use that address here. In case if you are connected to multiple devices on the same bus, then when you will scan, you will find array of addresses. So once this OLED is initialized, we'll use this show message to print some message in the display, and then clear display to clear the content of the display. And then I wrote one intro function which basically show learn to build, build to learn, and AWS IoT with some time gap. Similarly, another method tagline of my channel like eat sleep, AWS repeat. Then I invoked the init method to initialize that OLED display. Then I will use different method once it is initialized. So let's run this script. Now I'm going to call this intro method. Intro. So you can see it printed learn to build, build to learn, AWS and IoT. And to clear this message, we can call this clear display method, which basically fill the OLED with 0, then it call show function. So clear display, and it will clear the display. If you want to display any message, then you need to call this text function, which takes input message and the X and Y location. So you can try like this. Let's say OLED.text, say hello, and location maybe 2020. Then OLED show, you can see hello message. So similarly, I wrote another function which is tagline of my channel. Let's see how it looks. Tagline, enter. Eat, sleep, AWS repeat, awsjunkie.com. Let me know in the comment section, do you like this tagline or not? So now let's try the software I2C. I will not see much difference, but let me show you the usage. So instead of I2C class, we will use soft I2C class. So let's comment this one and uncomment this one. Just one noticeable difference here is that in the I2C constructor, we need to pass this hardware controller number 0 or 1. But in case of soft I2C, we do not have to pass anything. We can use any output capable pins as SCL SDA, and it will be controlled by CPU. And as there is no hardware controller, so you may notice some performance degradation, but in this case, we are just using display. There is no other processing going on, so you'll not see any difference. But let's try this one. Run script. Now Let invoke the last method tagline that we tried. Eat, sleep, AWS repeat, awsjunkie.com. So we have not seen any difference here. But when we will use this module for different functionality or functions that takes a lot of CPU power, in that case, you will notice some difference. So it's better to use hardware-based implementation, which will not only give you a better performance, reliability, it will also free up CPU. So CPU can be used for other valuable processing. Yeah, just want to share one thing that from this SSD 1306 driver module, we used I2C implementation, but there is another implementation is also available for this display driver, which is hardware-based and software-based SPI bus. We can quickly check here using help function, help SSD 1306. And there you can see there are two classes, SSD 1306 I2C and SPI. For this hands-on, we use I2C implementation. That's all for this video. Thanks for watching. See you in the next one.